Welcome to the Engineering 153 video that's going to discuss required tools. I'm John Waddick from the Engineering Science Department. I'll be joined today with Master Toolmaker Don Howard. In this video we're going to cover three things. Number one, look at the toolbox that you're going to need to carry your tools in. Number two, the tools that are going to be required for you to provide yourself. And finally, the parts supplied by your instructor. So we're going to start by discussing the required tools. All right, welcome to video number 2 for Engineering 153. I'm John Waddick along here with Don Howard. We're going to talk today about the required tools for Engineering 153. These are the things that you are required to have. We can say we can make it very easy, and it's been made easy for you because there's going to be this whole kit, including the toolbox, available in the bookstore for probably about $125. If you don't want to buy it in the bookstore, you don't have to, but if you do have financial aid, you can use it in the bookstore. If you don't get the bookstore variety, then you're going to have to get these things all separate. But let me start out and just review. In the kit will be a pair of safety glasses, maybe not exactly this variety, but there'll be safety glasses in there. One thing I wanted to remind you about from last time is whenever you're in the shop, you need to have your safety glasses, and they need to be on and worn properly. A lot of times we see students like this, Don, right? Wearing the glasses to, maybe protect the top of their head. Now, for some of us, like me, maybe there's not a lot to protect there. So your glasses need to be on and not on the top of your head. You keep them like this. Maybe you don't like them like this, but it'd be highly inconvenient in the rest of your life to have only one eye to see out of. So safety glasses are one thing. All right, you're going to get a permanent marker with a wide tip. Don, this seems like, why were we making posters over there in the shop? What's this used for?
Well, if you want to make a poster, go back to art school. But what we use a magic marker for a lot in the shop is for layout. We want to mark a part, we want to scribe lines on a part, and you're going to want to mark up your parts just for identification purposes. So that's why we would use a magic marker in the shop.
Yeah, because keep in mind, there's going to be probably about 70 students making parts over there, and they all look alike. And so you want to put your name on it. Don, we've got a couple devices here. What are these?
These are two different style of Allen wrenches. You have a metric set and you have an English set. All right, so you have an inch and metric. And you'll use these to put together your ENR car. You're going to be given a fastener kit later on in your class, and inside this fastener kit you'll see a number of different fasteners. You have cap screws, you have shoulder screws, you have nuts, bolts, and different variety set screws. You have Boston collars, all which will be using Allen head.
All right, so that's important for assembling your car later on in the course. Now similarly, Don, when we talk about assembly, students will also be getting this electronics kit, and I'll just give you a quick rundown of what's in here. You're going to have a microcontroller with a motor shield on it. That's going to control your motors and the navigation of your car when you're done. The servo motor, which is going to be used for steering, and then a DC drive motor, which will be for your propulsion. You don't have to worry about those yet. These are something that'll be given to you by your instructor later on. But many of the fasteners on these electronic boards are very small, and that brings up the next thing that's in the kit, which you're going to get a collection of what are known as small precision screwdrivers. Now you may have it in a kit in a little different form, but as you zoom in there on the board, you can see that these are very, very small screws. Regular screwdrivers that you would just buy at a hardware store are not going to cut it. They're just going to be too big. So as Don is showing, you're going to get a set of precision screwdrivers for the assembly of small parts on the electronics. So, all right, thank you, Don. We'll just put this back in, get it out of the way, and all right. So we've talked about a few of the things now. You're also going to get a adjustable wrench. I guess this is just kind of a utility tool, or Don has some ideas of what you might use this for.
Holding on your fasteners, you'll be using, along with using your Allen wrenches, you'll need to hold the fasteners with a adjustable wrench so that you may tighten down your fasteners so that you'll hold your components together.
All right, so you get a nice small adjustable wrench. Likewise, there may be some occasions to use these, which are...
This is a pair of needle nose pliers. Could be used for getting into tight spots to hold fasteners. Say you've got a fastener that's up behind a bracket or underneath a motor that you can't get your adjustable wrench in, so you would use this needle nose pliers to get up there and maybe pinch off the fastener so that you can tighten it up. The other thing you can use it for is if you're going to be given a piece of piano wire which you have to bend, you may be able to use this to bend and tweak your piano wire to fit into your drive mechanism, your steering mechanism.
All right, very good. All right, so let's see. We've gone through all the tools there, the fasteners. Now, the most expensive parts are up in here, okay? Well, at least this is the caliper, but we'll go over that last time. How about the steel rule there?
This 6-inch steel rule is an all-purpose tool that we use in the shop. You won't find a tool maker without it. Engineer can use it. They can carry it right in your shirt pocket no matter where you go. You're out in the field, you can measure anything. But you're going to use it for quick verification, layout. You'll use it for cutting your material. So it's a very handy tool to have, right down to even if you're a coffee drinker, you can stir your coffee.
All right, Don, will I need a pocket protector to use this in my pocket?
No.
Oh, okay. All right. So anyway, this is a utility measuring instrument. A lot of times when you don't have to get anything too precise, but just need a rough idea. Right. All right. Don, the most expensive by far, probably half of the cost of the kit is going to be in the caliper. Now we're showing a certain model. The one that's in your kit will be a different one, but a same general thing. So why don't you just give us a quick rundown of what this instrument is for, and how some ways you can use it.
Right. This instrument is used for measurement. All right, we can get down to thousandths repeatability for the most part with this tool.
So a thousandths, that's 0.001 inches.
That is correct. That's what the manufacturer will tell you that this is good for. What it is, it'll measure anything from 0 to 6 inches in size. As you can see, the jaw opens up and it closes up so that you can get the measurements. How do you use this? This one's electronic, so it's digital. You hit the on-off switch, you'll see you get numbers. First thing you're going to want to do is zero it. So you open and close it, and you close it on a jaw, and you can see we don't have 0. Always want to make sure that your jaws are clean. Close it up, and then we hit the 0 button on the side here, and you can zero your tool so that you will be accurately measuring your part. So if you could hand me a part, I can demonstrate.
Now here's an old car that was built when we had a little different design than what you have this semester, but this was a beautiful car and wheels that were all machined by an Engineering 153 student.
Now, the nice thing about this particular tool is not that it's just digital and it will read within a thousandths for you, is this is a multi-purpose tool. You're going to be able to read inside dimensions, outside dimensions, and you can also read depths, as I'll demonstrate for you now. If I want to read outside dimensions, I can read the outside of this dimension by simply taking this part and using these inner jaws, and I can reach across this part and I can get a dimension of my part. All right. If I want to get internal, as you can see here, I can go down inside this block. If you would hold that up for me, please. I can get inside this block and I can measure this profile, this internal profile. All right. And you can see I can see my numbers. All right.
So wait, so Don, can you just review it? There's inside diameters are used with the...
Inside are used with the top.
Top, okay.
Outside with these jaws.
Okay.
All right. And for depth, you got 2 different ways of doing depth. All right.
All right. So Don, would you just review for me? There seems to be 2 sets of jaws on there.
Right. 2 sets of jaws on a pair of calipers. This set of jaws is used for measuring the outside dimensions of a part, whether it be a diameter or a square, as I recently demonstrated. This set of jaws is for measuring internals, where I can either measure an internal rectangle or a shape or any kind of profile. I can measure a hole with it as well, and I can get hole sizes with it. All right. There's another way of measurement. There's 3 measurements you can get, and you can get depth. You can use the tail, they call this, in the vernier, from the beam to the bottom of here, and I can get depth. So as you can see, these wheels have a cutout in it. I can take this vernier I can set it down here, and I can measure a depth, and then I can read it off my dial.
All right, well, thanks, Don. So we can do outside diameters, insides, and depths with this one tool. Now, this is a tool that's most expensive, so you're going to want to take care of it. You're going to keep it clean. You don't want to be packing things up on it. Don, would this generally come in some kind of case?
Generally, they would come in a case for protection, but I would recommend if it does not, you need to get some to keep it in. You do not want to get chips or oils or anything, especially on this face.
So just throwing it in your toolbox and then piling all your parts on it is probably not the way to take care of it.
Absolutely not.
Okay.
Toolmaker would just destroy a toolmaker to see use like that.
All right. You also get a toolbox in the bookstore with your kit. If, once again, you're buying this by yourself, you're going to need something to carry your things, so a toolbox is going to be needed. Let me review the required tools that we discussed in the video. You're going to have these either bought in the kit from the bookstore, or you're going to have to go to a Home Depot or another type of hardware store to get these separately. Okay, first off is going to be a set of safety glasses. Okay, we've talked about those before. You need a permanent marker. It should be a wide point or a chisel tip, because sometimes you may have to be filling in a little bit. That's going to be used, remember, to identify your parts and for doing layouts. You need Allen wrenches, both metric and inch. Sometimes the inches are known as SAE. We showed a variety where they fold up. In the kit from the bookstore, you'll have actually a nicer set than what was shown here. A precision screwdriver set. That's going to be available in the bookstore. That's going to be needed for getting into all the very small fasteners in the electronics boards. You'll need an adjustable wrench, needle nose pliers, and those are going to be used for bending wire or getting hard to reach places. You need a 6-inch steel for doing quick measurements where extreme precision is not needed. You need a 6-inch caliper. That's the item that's most expensive. It's, the one in our kit that's probably around $60 or $70 itself. You need to have a reproducibility or repeatability of 1/1000th of an inch, 0.001 or better. So this is a precision instrument. So you'll be required to machine your parts to certain tolerances. So you need a good caliper. You really don't want to skimp on this item. And then finally, you need a toolbox to store your tools. The one in the bookstore is color-coded to the black and gold of the MCC colors. By the way, if you don't know, MCC's mascot is the Tribune. I'm not going to tell you what a Tribune is here, but maybe you can look it up. Now, also in the video, Don talked about the caliper operations. So let's just quickly review those. Remember, if you're buying this separately, you need one that has a repeatability or precision of 0.001 inches or better. When you're using your caliper, first thing you need to do is make sure your jaws are clean, so there's no chips or oil. Once you do that, you want to close your jaws and hit the 0 button so that your caliper is properly zeroed. And Don showed how to do a measurement with an outside diameter, an inside diameter, and then also a depth. So there's there's 2 different jaws, and then there's also the depth gauge on the caliper, and you should know how to use all those 3. And finally, this is a precision instrument. If you throw stuff on top of it, bend what's known as the beam or any of the jaws, is not going to work as it's been manufactured and designed to do. You need to put it in its own case. The one in the bookstore will have a case with it. If you buy it separately and there's not a case, you need to get yourself a case to protect it. The parts that are supplied by your instructor are going to include, first of all, the fastener kit. When you get to the point where your car is ready for assembly, your lecture instructor will issue you and your group a fastener kit. At the end of the semester, you'll have to bring that fastener kit along with your car to your final presentation period and hand that back in, okay, along with all the fasteners. The fastener kit has a whole set of cap screws, shoulder screws. Some of these shoulder screws are almost $2 each, so that's why we're going to want them back. These are very expensive precision ground screws used for bearing surfaces for your wheels and steering components. Boston collars, sometimes called shaft collars. There's some of those. Obviously some nuts to hold the screws down. And then we're talking about an electronics kit. The electronics kit is, there's probably components worth well over $100 here, and these are only going to be issued to you during class time. So unlike the fastener kit, where you're going to be given a set, each group is going to be given a set, and you're going to have that to keep until the end of the semester, the electronics kit is only going to be issued to you during your class time by your lecture instructor. So you can't take the electronics kit home. It's used in the lab period, or in your class period only. And that kit's going to have a microcontroller that's going to be pre-programmed for you so that your car will automatically navigate and go around the track properly. You don't have to program it. It's going to have a motor driver, sometimes called a motor shield, so that we can turn your motors on and off and control them. You're also going to have a servo motor used for steering, a drive motor used for propulsion, and not shown in this video, but you're also going to be given AA rechargeable batteries that you can exchange whenever needed and get them recharged by our lab technician. So that's the parts supplied by the instructors. Okay, fastener kit, you get to keep that the whole semester, then return it at the end. Electronics kit, you have to check that out just during your class time and have to hand it in at the end. So here's some questions that we'd like you to answer and hand in to your lab instructor. Number 1, Waddick showed an incorrect way to wear safety glasses in this video. Described how he was wearing them and why this is not acceptable. Number 2, make a list of all the required tools that are included in the Engineering 153 toolkit that will be available for purchase in the MCC bookstore. Number 3, what item is the most expensive tool, and this is the most expensive by far, in the Engineering 153 kit? How should this item be stored in your toolbox? 4 is make a rough drawing of a caliper. Now this doesn't have to be completely perfect realism here, just the rough idea. So draw a caliper and label where you would measure an inside diameter, an outside diameter, and the depth. Last question, how will the fastener kit and electronics kit be distributed by your lecture instructor? So in other words, how long will you have each of these kits for, and when do you have to return them each time you check them out? Alright, thanks for coming to this video, and I hope you get a nice toolkit. This toolkit will be used again in the future when you get into other design projects throughout the program.